In this session, let's start looking at some of the miscellaneous aspects like membership, testing for a membership of a specific class, whether a particular vector belongs to a specific class or not, or we are talking about coercing, where we are dealing with converting from one class to the other class. We'll also deal with a few other things like dealing with the missing values, which are generally denoted by NA. How do I deal with them? Then there is something called infinite. So how do we deal with this infinite? And especially some kind of weird calculations, let's say 0 by 0 kind of calculation, which result in not numbers, which are typically called as NaN, which is like not a number. How do we deal with all these different kinds of things? That's what I'm dealing as a part of this session. So first part, dealing with membership and coercion. Membership is checking the class of an object. So we have all these different classes. We have a class called array, we have a class called character. Complex character is nothing but string, but we will be using the word called character here. Then we have an object called data frame. We have double. Double is more like floating point kind of numbers can get handled through double. Then we have factor. List, I'll deal with the word list, and so these are some complex data types. Probably the list, the data frame. These things I'll come across, I'll get them across to you at a later point in time. The matrix, we have already seen logical, we know numeric, raw, time series, again I'll get it slightly later, and again it's a vector. So these are different kinds of data types. So we can test any of these data types using is dot, right? And when I'm talking about coercion, I'm converting any data type to that specific. When I say as dot array, I'm converting something into an array. I'm saying as dot data frame, data dot frame, I'm converting a regular vector into a data frame. Or probably I can say as dot vector, as dot logical, as dot numeric, as dot integer. We can create any other data type into the data type of our choice by using as dot. But remember, only if there is a compatibility, right? It's like if I have an original vector x, taking the values, let's say a, b, c, which are characters, right? Now I can't say as dot integer x, right? Because of course these numbers cannot be converted into integers, so there is I can't convert them. But probably if let's say x is having 1, 2, 3 as numbers, which are showing a data type called numeric. Now if required I can convert them into integers because they are compatible. So compatibility still matters, but wherever it is compatible, at least I should be able to convert it from one type to the other, right? So we can really check different kinds of data types. So probably if I am saying I have a variable a which is taking the values true, false, false, true, right? Let's say so there are only logical values. So that's where I want to check is logical a. That is coming out true. But if at the same time if I say is numeric a, it gives me false because it's not numeric, right? But if I want, I can convert it into numeric as numeric a. So because by default true is assigned 1, false is assigned 0, as dot numeric will make it 1001. But now this will not be, if I say is logical, and inside I am checking as dot numeric a. So I have converted it into numeric, and after that I am checking whether it is logical or not. Then it is directly giving me false. So it is one data type at any point in time. Now similarly, if I want to convert a into factor, so I'll create b, wherein I say as dot factor a. Now what is happening to b? If you look at true, false, false, true, the levels are coming out as false and true. Now if I say is dot logical b, now b is no more logical. But if I want to say is dot factor b, yes, it shows me true, because we have already converted it into a factor, right? So we can very well test, or even that factors now, right now they are factors. Factors let's see, can we convert them into numbers? So I'll say is C is as dot numeric B. Can I do that? Now if you look at C, it is giving me 2, 1, 1, 2. Because now it has assigned, as factors it is assigning 1, 2, 3, 4. False is assigned a value of 1, true is assigned a value of 2. So I'm getting them as 2, 1, 1, 2. So we have A, which is logical. These are all interconvertible, right? B, which is a factor. C, which is a numeric. You can very well convert them into the types of your chart. But wherever there is no compatibility, let's say I'm having D, which is taking A, B, C. Right? Let's say there is a D which is taking these three values A, B, C. When I display D, these are the things that are coming. But let's say I want to look at is dot character of D. It says yes. Then I want to convert E. I want to create E, which is as dot numeric D. Now E can't be converted. So that's where it says N is introduced by coercion. So it will not be converted. Now if you display E, it is showing NA, because you can't really convert a character into a number. But character can very well be converted into a factor. Now let's see E as dot factor of D. Now if you look at E, it says A, B, C, and these are factors. So some of them are interconvertible. We really need to know what data types are interconvertible, use them accordingly. Right? The other thing, let's say I want to perform, I have a vector, let's say I have a vector X which is taking 1 to 10. I have a vector Y which is taking 1 to 3. Now I want to multiply X and Y, right? I say X multiplied by Y. Now you see, how did I get these values? X is having the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y is having 1, 2, 3. Now what happens is this 1, 2, 3 will get repeated until the length matches. Now the multiplication happens pairwise. 1 multiplied by 1 is 1, 2 multiplied by 2 is 4, 9, 4 multiplied by 1 is 4, 10, 18, 7, 16, 27, 10. So these would be the values that are displayed as a part of this multiplication. And there is a warning message. The longer object length is not a multiple of the shorter object length. The shorter object is typically repeated until the length matches the longer object. So vectors, when we are doing the calculation from others, the new vector will be as long as the longest vector, and the shortest vector is recycled as and when necessary until the length of it matches the longest vector. So that is one thing we have to remember whenever we are doing any kind of a multiplication or any kind of an addition. Even the same thing goes with x plus y or any other calculation. When we are adding two vectors or multiplying two vectors, it will internally make sure that the length of both the vectors will be the same. The shorter one is recycled or repeated until it matches the length of the longer one, and after that the calculations are typically done. And if the shorter one is not the longer one is not a perfect multiple of the shorter one, will get a warning message, but the calculation will typically proceed. Then there are a lot of things in R, a lot of calculations that can come out. Let's say I divide a number by 0, I'll get INF, which is what we call as infinite. Minus 3 I divide by 0, I get minus infinite. So these are two different kinds of values that we see, infinity and minus infinite. So we can do different kinds of calculations also. Let's say I am doing an exponent of INF. It gives me INF. But if I take e to the power of minus INF, e to the power of minus infinity is 0. But in some cases, if I say infinity plus infinity, it is still infinity. But infinity minus infinity, there is no meaning to infinity minus infinity. That's where it is giving me not a number. Right? Or what about infinity divided by infinity? Even that is not a number. 0 by 0, that is not a number. So there are different kinds of not a numbers that are there. So we have to differentiate between these. Which ones come out to infinite, which ones evaluate to minus infinite, and which of them evaluate to not a number. And remember, this has to be differentiated from NA. NA is not available, and this is not a number. This is more to do with the calculation. The calculation, if it is not able to do, we get not a number. But not available is more like a missing value. I can't mix these two things. I have to really differentiate between these two aspects. Right? And especially missing values are much more painful. They are very, very irritating. Especially when I am talking about a tabular data, right? Where I have different records and I want to fit a kind of a statistical or mathematical model based on my data. And for one of the variables, there's a lot of missing data. Now, how do I really go about in terms of creating my model? That's what makes it more and more irritating. The model fitting operation becomes more and more problematic. That's where we need to have a mechanism to handle the missing values in a much, much effective manner. They are going to reduce the power of our modeling. They are reducing the effectiveness of our model. So we really need to have mechanisms on how do we really address them. Right? So even when we are talking about with respect to infinite and not a numbers, etc., we still have membership functions as well as coercion functions even for that. We can use is finite, is dot infinite, right? Is dot na. Let's say we'll handle the is dot na stuff. Let's say I have some y which is taking three values, 1, 2, 3, and probably na, four values. Right? So there are four values, the first three are existing, the fourth one is a missing value. Now I say is dot na y. So okay, is dot na y. False, 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 true. The first three are giving false because they are not NAs, and the last one is an NA, so it is working out to true. Now I really want to filter it off. Right? I want to show only those ones that are not NAs. So what do I do? Okay, I want that Y, but I don't want all the Y. I want only selective one. So if I want to select only a few values out of my total vector, that is where I use a square bracket notation, where I am taking some subset of my total y. Now what is that subset that I want where it is not NA? So the negative of is NA of y I am going to take. So negative of is not is dot NA of y. If I am doing is the whole NAs are filtered out. I'm just getting 1, 2, 3, right? So that's one way where I can remove out is dot NA of y from my list, and only the ones which are not NA I can pull them off, right? And even a few more things, right? If I want, I can remove that, stripping out the NA, and I can very well retrieve the list. Now if I really want to know which NA out of this, I mean these are the values, or probably let me create a big list, right? Let me now create y, which is having, let's say, 1 to 6, then NA, right? Then 7 to 10, then again NA, then another NA, then 11 to 18. Let's say this is my big list of y. So there are some NAs which I am observing, right? Now I really want to know which of these NAs. See, first of all, if I want to test is dot NA of y, I'll get false, 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 false. Now, which locations of NA are y? Which locations of y are NA? If I want to know, I can simply say which. I can simply say which, and which is NA. So I can say which, and I say is dot NA of y. So which of them are typically NAs? So it says 7th element, 12th element, and 13th element are NAs in this whole list. So if I really want to know which of them, the location of any of the values, I can use something called which can help me to trace it. And if I want to replace the ones that are not NA, or probably if I really want to replace all NAs with 0, right? I want to replace all NAs with 0. What is that I can do? In case, let's say my y, any of the y's, so I'm looking at the y associated with is NA, is dot NA of y, right? I'm putting it in square brackets because out of that y I'm picking out where the NAs have come. So that particular location I am replacing them with zeros. Now if you click on y, you are seeing that NA is replaced with a 0, because you are finding out is NA of y, and wherever it is saying true, so only y of those, y is the subscript, I mean the whole list is y. Out of that I am only taking some subset, and those subsets are where it is equal to NA, and those are you are replacing with zeros. So you are getting a new number here. That is one way you can handle, right? If you want to go back again, so y, right, I can put, let's say, all zeros I want to replace them with NA. So I can simply say y, which y equal to 0. So where all y is equal to 0, I will replace them with NA, missing values. Wherever I got y as 0, I'll replace them with the missing value. So when I say now y, again all the zeros are replaced with missing values. So we can use which to get the location, and y within the square brackets is a meaning that we are taking that subset of that particular location. So this is one way. And probably here the biggest problem is we can also use, okay, I'll come back to that. On this, let's say I want to find the mean, right? Let me find out simple thing, mean of y. I'll get it as NA. So many calculations, if I find out, let's say I'm doing the variance of y, it's giving me NA. There are a lot of calculations, the specific functions which I am using. If there is NA in my data, my results are very much irritating. So one way to handle them is, okay, I'll do the mean of y, whereas I want to remove all the NAs. So this is where I use an additional term here, na.rm. na.rm is remove NAs is true. I can write T or true. So when I find the mean of y, where the NA is removed, in that case the mean gets computed. The same thing holds for all of them. na.rm equal to true. So I'll get the variance, all the computations which by default are giving NA as the outcome. If I remove the NA, I can still get the actual values. NA will be removed and the computation will be taken place. Now, we have already done wherever NA is there, we have replaced it with 0. The other way of handling the same is we can use if-else kind of a construct. Right? I'll of course talk about this if-else slightly later. But what we simply say, if-else is NA of y. So if something is NA of y, replace it with 0. Otherwise, replace it with y itself. Keep it as y only. Even then, everything is. So if I want to replace something with something else and the remaining you can keep them as it is. Another important statement that can come to your rescue is the if-else. So if something happens, do this, otherwise do something else. So in this, we really need to get a hold of these initial elements. How do we handle all the missing values, right? How do we replace them with something? How do we check the membership, coercions? All these things become very important for our further understanding of the subject, right? So we come across a lot of these missing values and all when we are working with big data sets. So we need to have a mechanism. How do we really go ahead in terms of replacing them? Or how do we handle them? If not replace, what else are we going to do with them? If I have to keep them as it is and compute my mean and all, how do I really go forward? So, I hope you got a comfortable amount of idea in terms of handling these elements. If you have any further queries, you can get back to me by giving me a call on the number below, or you can send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.